My name is Clayton Turner. I'm the Chief Engineer at Langley Research Center. I work in the Office of Director. I'm responsible for the technical excellence of every engineering activity that goes on here at the center. That ranges from aeronautics projects through earth science, planetary science, and human exploration. I got involved in NASA through the typical interview process. I graduated from Rochester Institute of Technology. I took interviews with several government agencies and private industry. Upon coming to NASA, I was able to tour the facility for a bit and saw some folks working on the HALO instrument. And I was really impressed by their dedication and service and the excitement they showed when they were doing their work. I've worked on a number of projects. One of them is a LiDAR in space technology experiment. It's the largest or highest powered commercial civilian laser that's ever flown in space. This was launched on the space shuttle. I was responsible for the mechanism that aimed the laser. This was very challenging. It was very interesting, and it was very exciting for my first time out as a college graduate. In addition to that, I worked on the gas and aerosol monitoring system. That was a small satellite that was a free flyer that monitored the constituents in the Earth's atmosphere. The idea was to build many of these and put them up in orbit and be much cheaper than building very large dedicated satellites. Other projects I've worked on, Ares 1X, which was a recent launch of the largest rocket we've built in NASA since Saturn V. That was a collaboration of multiple centers across the agency, industry partners. We did it in about 2.5 years and within cost and budget, and we all got to see a very exciting launch, and that will be the precursor to what we're going to use for human spaceflight going into the future. The most exciting aspect of my job is the chance to do something for the nation. Working for the government, working for NASA in particular, we get an opportunity to influence the future. There are not many places where you can do work that'll change the lives of people in 10, 20, and 30 years. We literally have to look out into the future and decide what's going to be best for the nation. We have to also work in conjunction with what the President directs us to do and what Congress funds us to do. In some cases that may seem confusing, but they always give us a direction that will help us serve the nation, and that's what we really want to do. Everybody you see wearing this NASA badge has a deep interest in serving the nation and doing those things that will make us stronger as a nation and serve the planet. Many of the topics I studied in school were foundational. Obviously math and science were key as an electrical engineer for me, but also history and English. You need to understand how to communicate. You need to understand what's been done in the context, not only technically, but in the history of the world, what those technical accomplishments have done to advance life on the planet. Putting those things together, that builds you a good foundation, but you also have to understand how to work with teams, how to work with people. You need to be able to achieve in very, very difficult situations. Here at NASA, we don't do a lot of anything. If there's something that can be done 100 of, 1,000 of, 1,000,000 of, then somebody else should be doing it. We should be doing those one-of-a-kind, very, very difficult things, those things that are extremely challenging. And to do that, you have to understand how to work with discomfort, you have to work in teams, and you have to work through healthy conflict. And that's usually a challenge, but that's something that you have to do to be able to get to the really complex ends.